A very good morning to all my dear students. So far we have studied least squares method from the chapter time series. A complete review we shall consider now based on least squares method, which we have solved the problems for the past 6 to 7 videos. All those consolidated review we shall have once, because these are very important 10 mark compulsory question, from question paper. Fine, let us have a complete review on method of least squares. First, we had come across under method of least squares straight line trend equation, or else it will be called as linear trend equation, or else it will be called as first degree trend equation. Along with the video, try to recall before it appears on the screen. I mean to tell, all those methodologies which you have learnt already, try to recall before it appears on the screen and get it verified. So what is straight line equation? Y is equal to a plus bx. You know already, x is what? X are time points. And what about y? Y are the given values in accordance with those time points x. And what are a and b? A and b are constants to be determined, to be calculated. Fine. After having got the straight line equation, or an equation which is in the form of linear or first degree equation, what else we will be following in order to fit this equation? Fitting of linear or straight line equation, what were we following in terms of problem solving? Next, it is to be considered normal equations. How to form normal equations also you can recall. So first normal equation was applying summation to this particular equation. What it will become? Summation of y is equal to summation of a constant. You know already, any constant, if it is summed over n times, it will become n multiplied by that particular constant, so that it will become na plus b as a constant outside. Summation is being applied to only variables, that's why summation of x is remaining. This is first normal equation. Fine. Second normal equation, how to be found out? By applying summation of x to this particular equation, we will be getting second normal equation. So summation of x, when it is being applied here, concentrate on the cursor. Summation of x when it is being applied here, y is already there, both x and y are variable, so that summation of x is applied and y as it is carried out here, both x, y will be under summation, is equal to a is there, summation of x is being applied, a will be constant, so a can be kept aside, and then summation of x will be present. Then after that plus b as a constant outside, x is already there, and one more summation of x you are applying, so that it will become summation of x square. In this straight line equation, how many unknown constants are there? A and b. Two unknown constants are there. So in order to find out two unknown constants, it's sufficient to have two normal equations. Using these two normal equations, we can calculate these two constants. Fine. After this, what we have to do, or what we had done, try to recall. Summation of x to b is equal to 0. That form we have to arrive at in the given values or given data. Once when summation of x is equal to 0, that means When summation of x is equal to 0, what happens to these two equations we have to see. What will it become? First normal equation. Again, I am asking you to concentrate completely on the cursor continuously. So here b summation of x is there, sum of x is equal to 0, this will become 0, so that summation of y is equal to NA, it becomes a we want, so that sum of y is equal to, a is equal to sum of y divided by n it will become, so that implies a is equal to sum of y divided by n. And what happens to this equation? Sum of x is equal to 0. This term is entirely goes 0. So what we want? B we want. B can be retained as it is. Here it is sum of xy divided by sum of x square it will become. So that B is equal to sum of xy divided by summation of x square. After having got these two constants, what we had done? With the help of given values, we will be able to substitute here sum of y, n, sum of xy, sum of x square and all those. After having substituted numerical values over here, we will be getting a and b as constant numerical values. After having got these constants in terms of numerical value, what is to be done? These are to be substituted in the main equation which we had written as a trend equation. So a and b, after substituting here those constants numericals, by substituting different values of x, we will be able to get at that instant of x value what will be y value. Hope you are following me, students. A and b are the constants. After substituting here, we can substitute numerous values of x in order to get y values at that particular x value. Fine. So this was straight line or linear or first degree trend equation, and accordingly we had come across two more methods. In that next we shall consider now to be quadratic, parabolic or second degree trend equation. All the names you need to remember. Sometimes it may be called as quadratic, sometimes it may be parabolic, sometimes it may be second degree in your question paper. So you should get every such names, second name, third name of particular concept, you should remember, so that the questions can be tackled very easily in terms of examination in future. Fine. What was quadratic equation? It is second degree equation. Earlier it was straight line equation was to be considered as first degree equation, just because x to the power 1 only we were stopping at. Y is equal to a plus bx. This much only was there earlier. Y is equal to a plus bx. X to the power 1 it was. That's why it was to be called as first degree equation. Now this equation is y is equal to a plus bx plus further cx square is also there. We are landing as x square. That's why it will be called as second degree equation. Fine. After this, usual procedure. What is it? Normal equation finding out. First apply summation to this. When you apply summation to this, what happens? Sum of y is equal to, already sum of a is equal to NA plus b is a constant, keep it outside. X is there, apply sum to that, summation of x plus in between this plus. C is a constant, keep it outside. Sum is being applied to x square. This is first normal equation. And second normal equation is apply to the same equation. Look at the cursor. To the same equation it is to be applied now. Summation of x. First summation, then summation of x you are applying. Once when you apply summation of x, what happens? Summation of x, y is already there. That's why summation of xy is equal to a constant, keep it outside, and summation of x you are applying, plus as it is b, keep it outside, being constant, summation of x to be applied, x is already there, it will become summation of x square, plus c being constant, keep it outside, summation of x to be applied, x square is already there, x multiplied by x square will become sum of x cube. And after that, how many constants are there here? A, B and C. Once when three constants are there, we cannot calculate only with the help of two equations, three constants. That's why one more equation we need. That's why, apply summation of x square to this particular equation. First we had applied in order to get this normal equation summation. In order to get this equation, summation of x is applied. Now let us apply summation of x square. So summation of x square, when you apply summation of x square here, y as it is already there, that's why summation of x square it becomes is equal to a, summation of x square is being applied, so summation of x square is being written, plus in between b, keep it outside, summation of x square is being applied, when x is already there it will become summation of x cube, plus in between, then c being constant, keep it outside, summation of x square is being applied, x square is already there, x square multiplied by x square will become x to the power 4. So these are the three normal equations which will be used to find out the constants a, b and c. What will be the next step? You know already, try to recall. What will be the next step? When summation of x is equal to 0, what happens? So when summation of x is equal to 0, what happens to these normal equations we need to observe? Once when summation of x is equal to 0, you know already summation of x cube also will be is equal to 0. Correct? Fine. So consider this second normal equation. Look at the cursor, second normal equation you consider. Summation of x once when it is equal to 0, this term is equal to 0. Summation of x cube when it is equal to 0, this term also equal to 0. So this as well as this term is entirely is equal to 0. So now what remains in this? Summation of xy is equal to b summation of x square. Now we want b. So this summation of x square can be taken here in terms of left hand side, which becomes divided by. So b is equal to summation of xy divided by summation of x square it becomes. That's what we have written over here. B is equal to summation of xy divided by summation of x square. Directly we are able to calculate b value. So we know already all these, sum of xy, sum of x square, sum of x cube, sum of x4, x to the power 4, all those are to be calculated based on the data given. That is second matter. Now theoretically let us understand and have a complete knowledge about it, so that problem solving will be very easier task and 10 mark we can obtain in the examination. Fine. So this second normal equation we have considered in order to calculate b, which are remaining this first normal equation and the third normal equation. What it happens to first normal equation? Once when summation of x is equal to 0, this term goes to 0. What it remains? It remains sum of y is equal to NA, concentrate on cursor, plus as it is. So this term is 0 plus c summation of x square. And then what about this equation, third normal equation? Summation of x square y is equal to summation of x square plus b summation of x cube is equal to 0, because sum of x cube is equal to 0 once when sum of x is equal to 0. then plus c summation x to the power 4. Correct? So here the values have to be substituted. After substituting values, two equations we will be getting. Simultaneously solve these two equations. Either A or C you will be able to calculate. Once after getting either A or C, substitute in any of these two equations in order to get the remaining one, the later one. So after this, A, B, C, all the three constants we will be getting. Once after getting A, B, C, the constants, here in the main equation, those values have to be substituted. After that, with the different values, various values of x, we will be able to calculate y as the trend values in those time points. Hope you are getting clear idea, students. Then next, one more method we have learnt. What was it? The last one very recently which we have learnt. Try to recall which we have learnt. It was logarithmic equation, or else what it will be called? An exponential equation. Fine. It is an exponential equation or logarithmic trend equation. What was it? The equation y is equal to a b to the power x. Again, I am asking you to concentrate. This is not a b whole to the power x. It is just a multiplied by b to the power x. How many constants are there? A and b, two constants. And we know x is time points, y is values at those time points. Fine. In order to calculate these two normal equations, we need, these two constants, we need two normal equations. I mean to tell, to calculate these two constants, a and b, we need two normal equations. By applying summation to this and by applying summation of x to this, we will be able to get. For our simplicity, or for our convenience, this exponential equation is being converted as logarithmic equation by applying logarithm to this particular equation. So what will it become? Y is there in the left hand side. Once when you apply logarithm to that, it will become log y is equal to log a. Multiplication, when it is there between two values, when you apply logarithm, it will become plus. You know that already, and I have already explained in my previous videos. So it will become log a plus in between b to the power x. When it is there, by applying logarithm, it will become x log b. Okay, this will be called as logarithmic equation, and this will be called as an exponential equation. By applying summation to this, what you will get? Summation of log y is equal to, log a is a constant, so that n log a when you take sum, and plus log b is a constant, x you will be applying summation, so that it will be summation of x. And then what it happens? Summation of x, when you apply to this particular equation, it will become sum of x log y is equal to log a. Summation of x is being applied. Log a is a constant, keep it outside, plus in between. Log b is constant, and summation of x is being applied, and one x is already there, so that it will become summation of x square. As usual method, once when summation of x is equal to 0, what happens? This term goes to 0. Summation of x is equal to 0 means, so with the remaining part from the first normal equation, we will be able to get log a is equal to sum of log y divided by this n. And what happens to this equation? Summation of x is equal to 0, this term goes to 0. With the available log b, what happens we should see. And before that, we can even observe, once when log a is equal to this much, what will be a? A will be antilog of this. A is equal to antilog of this particular aspect. And then here, so this term goes to 0, and with the remaining one, log b is equal to summation of x log y divided by sum of x square, and b, if you have to calculate, it will become antilog of this. So we got a we have got, b we have got, or else in terms of log a and log b also we have got. So a and b can be substituted in this equation, or else log a and log b can be substituted in this equation in order to find out either y values or log y values as trend values. So we have already learnt all these in previous classes, and now we have recalled it in order to get some more perfection into it. So concentrate properly, practice well, so that you will not have any problem later with the heavy syllabus. Stay home, stay safe, and take care, students. Let's see some more concept remaining from time series in the next video class.